Hi, welcome. This is Module 1, the Overview of Data Centers, Part 1. We're going to split this module into a couple different parts because we really think it's important to kind of go through and look at a little bit of the evolution of the data center and where we are today and where we need to be as we move forward. Remember, as we go through here, if there are any questions, you can use the question comment box. That will send an email right to me, and we'll be able to either answer a question you might have on a slide, or if you want some expanded information, you might be able to do that as well. So let's get started. Let's look at what we're going to cover in this module. We're going to look at what is a data center, right? So all the way back to the beginning, what is a data center? So we're all kind of on the same page because a lot of people have different opinions of what a data center is. We're going to look at some of the current trends shaping data center design. So when we're going out to design a data center, what should we be looking at? What are the key parameters that we want to look at in order to correctly design a data center? And we want to look at tiering in the data center. Data center tiering is all about reliability and availability in the data center. We live in a very exponential world. It's a little chart here, just kind of give you an example of how fast things are moving these days. So it took 38 years for radio to get a target market of 50 million people. 38 years once radio was introduced, before 50 million people were listening to the radio. Television, only 13 years. The internet, 4 years. iPod, 3 years. Facebook, 2 years. Faster and faster this market is moving. There's somebody in a garage right now inventing some app that's going to hit 20 million people in its first week of being out there. That's how quickly things are moving these days. These are the 2009 populations of the world, of the top 10 countries or so. If Facebook were a country, it would be the third largest country in the world. My daughter has spent some time in Africa. She works for a nonprofit, works with severely malnourished kids, and she was in a little village in Malawi, Africa. A very poor village, but they do have a village laptop. Once a week they can get a kind of a landline modem connection, and kids there are her Facebook friends now. So it's amazing the connectivity that there is in the world now. First commercial text message was sent in 1992. Today, there are more messages sent and received than there are people in the world. And not all of them are coming from my teenage son, right? We just are used to smartphones, instant communication. It's a very fast-paced world when it comes to IT these days. So why is this important to us? What's this have to do with data centers? All of these millions of web pages that are out there, all of these millions of Facebook users, all of these billions of Google searches that are happening every day, all of these billions of text messages, these are all provided by servers, and what's important to us, they're supporting infrastructure. So without the servers, without the network equipment, without the UPSs and the PDUs and the cooling units and so on, none of these things happen without all of those. So it's important to understand from a data center perspective what it is we're providing. We're really providing information for the entire world, right? So we've got an important job. We'd like to do it right. Data centers used to be these big mainframes, right? They were sitting back in the back room, and there were guys in white coats, and they had punch cards in their pocket, and they actually used those punch cards to boot these computers, and they were kind of a necessary evil. Today, things have really changed. Data centers today are a big topic of information in a boardroom, right? Because data centers are so expensive to build, sometimes hundreds of millions of dollars. But think of the other thing that we're providing. A lot of companies now, their product is information, right? Google, what is their product? You can't go and buy a Google widget, but you're buying Google information. You're buying information from Yahoo, right? So our product, financial institutions, these trade transactions and things like that, these are all provided by data centers. So data centers evolved from this IT department to really being a key topic in the boardroom. So what is a data center? And I bring this up because a lot of people will have a different view of what a data center is. I was in Brazil 2 years ago in the state of Minas Gerais. We went down to do a project for the Brazilian government. And the project was to go and look at their data centers, their state-run data centers, and see how well they were performing. So they wanted us to come in and say, evaluate our data centers, see how well they're doing. The second part was, after looking at all of these state-run data centers, what would a whole state-run data center look like, right? If we conglomerated, if we congregated all of this equipment into one data center, what would that data center look like? So some people, when they say data center, they say computer room. Data center, TRE, depending on where we're at. A server room, a network closet, telecommunications room. All of these in their own right are kind of a data center. When we were in Brazil, the very first data center we went to was run by the Department of Finance, right? They've got all the money. So their data center was very, very nice. It wasn't huge, but very state-of-the-art. Security was very good. State-of-the-art cooling, state-of-the-art power. There were a few suggestions we had to improve operations, but overall it was great. Next data center we went to was in the Department of Education, and they didn't have any money. So their data center consisted of a bunch of tower computers sitting on tables with a room air conditioner. Then we went to Department of Health and Human Resources, and they had 3 or 4 racks that were kind of back in a closet. But all of these were considered data centers. So we really want to look at what is a data center. What's the definition of a data center? So here's the chart I was talking about. Modularity increases efficiency. So down on our little x-axis down at the bottom, we have the percent load, right? So how much am I using my equipment? Am I using 20% of it, 30% of it, 50% of it, right? On the left side, we have how energy efficient is my piece of equipment, right? So you notice as my load goes up, as I go from 10 to 20 all the way up to 100, my energy efficiency increases as we move along. Okay? This is very, very important. Most of the time in the data center, if we look at a server, we might be using a server 6 to 10% of a server. So we're very, very lightly loaded. We're also going to have very poor efficiency on that server. Let's look at a UPS. A typical UPS might be 30% loaded, right? If I could take that same UPS and load it to 50 or 60%, that UPS is going to be much more energy efficient. Works the same thing with power supplies and UPSs and PDUs and cooling units. The more and more I load these up, the more energy efficient they become. That's why modularity matters. It's very, very important. The closer I am to 100% of capacity, that's the closest I'm going to get to my most energy efficient data center. And I know we'll talk about availability and we'll talk about reliability and things like that. So a lot of times what we'll do is we'll put a lot more equipment in there because we want to be redundant, right? We want to make sure that we've got backups and things like that. That's going to cut into our energy efficiency. We'll talk quite a bit about that when we get to the energy efficiency modules. But the key way to keep our data center operating in high capacity is building it out as we need it. If I only need 100 kilowatts now, let's build the infrastructure to support what I need. As I grow, I build more infrastructure. So it's important that we plan that from the beginning. Cooling is a key part of the data center. Data center density continues to grow. By density, I mean how much power are we using at a rack level. So a typical data center was built for maybe 3 kilowatts of power in a rack. Now we've got racks that are using 5, 10, sometimes above 20 kilowatts of power. Cooling that becomes very, very difficult. It's a whole different model that we have to look at as this data center density increases. Size of the data center is often a key factor when we're trying to figure out which cooling option should I choose. Right? Should I go with perimeter cooling? Right? A large data center might use raised floor and perimeter chillers. Small data center might make more sense to put the cooling devices closer to the racks. So starting to look at in-rack cooling, in-row cooling, and so on, and all the way down to individual rack cooling. So the size of the data center is a key component on that. So we need to look at our data center up front before we design it and figure out what makes the most sense as we're moving forward. Technology has a big impact on cost. So if I have not replaced my power in 20 years or my cooling in 15 years, it's probably worth my while to look and see what's out there today, because technology has improved the energy efficiency and operation of a lot of these pieces of equipment. So it's important to keep up with the technology as we move forward as well. And that helps if we're building modularly. If I try to build my entire data center now and I'm going to run with it for the next 20 years, I'm kind of stuck with today's technology. If I build what I need now and grow as I need to, I can grow with the technology. Operational costs of my worst cooling system can be 2.5 times worse than my best system. So I might go out and say, wow, I could buy this cooling right here and it's pretty cheap, but is it really cheap? Because over time, if I can buy this more expensive equipment that's 2 times as efficient, I'm probably going to save money operationally. So I want to look at more than just my capital costs when I'm building a data center. Virtualized everything. So there's a lot of virtualization benefits, right? So greater flexibility, more efficient use of resources, right? I'm going to run my servers at higher CPU usage. That's going to improve my energy efficiency. So virtualization helps me not only from a business standpoint, it also helps me from an energy efficiency standpoint. But we can't stop at the servers. We need to also virtualize our storage infrastructure. People forget about storage because we concentrate on the servers and UPSs and things like that. Storage is a big component of cost in the data center. So we can't forget about that, and we want to use our storage as effectively as possible as well. Self-diagnosing data centers. As data center managers, we're increasingly being asked to do more with less. Right? They cut budgets, so less people, but I've got more and more technology in the data center, so it's harder to keep track of all of that stuff. So we're looking for tools out there. We're looking for systems that will help us run these data centers more intelligently. So things like real-time monitoring, automated IT asset management. Where are all my assets? What rack is this server in? Where's that storage unit? How efficiently is this UPS operating? It's important to know that and have systems in place that will help me to manage that. Capacity planning. I want to grow in a modular fashion, but I don't want to get caught without the space, power, and cooling that I need. So it's important that I can accurately plan my capacity, know when to buy more equipment. Energy efficiency. Data centers are very, very expensive to run, right? And bottom line is, the more money we're spending on data center, less money is going into our paycheck, right? So it's worth our while to make that data center run more energy efficiently. Data center tiering. So data center tiers, we hear people talk about, oh, I'm a tier 1 data center, I'm a tier 2 data center, and so on. This tiering system is all about availability of the data center. These were designed by the Uptime Institute, and they have 4 basic tier levels. Tier 1 is basic, Tier 2 is redundant capacity component, and we'll go into detail on each one of these. I want to introduce them to start with. Tier 3 is concurrently maintainable infrastructure, and Tier 4 is fault-tolerant site infrastructure. Our availability, the amount of time that our data center is up, is going to increase as we go from Tier 1 to Tier 2 to Tier 3 and to Tier 4, right? Our cost is also going to increase right along with it. As we go from Tier 1 to Tier 2 to Tier 3 and Tier 4, our cost is going to go up right with those. So we're paying a couple of different trade-offs. One, we're going to pay a trade-off between cost and availability. Also, we're going to see that energy efficiency plays into this as well. So let's look at Tier 1. Tier 1 is about as low as we can get, although I've been to some data centers that are probably not quite a Tier 1 even. Let's look at the fundamental requirement. We have non-redundant capacity components. So what does this mean? Non-redundant means I don't have any backup. Maybe I have enough cooling in my data center. I have a computer or air conditioner that will cool my data center. But what happens if that breaks? I don't have a spare. Second part of this is a non-redundant distribution path. When I say distribution path, all about electricity, right? It's all about how is the power getting to my equipment, right? On a tier 1, both of these are non-redundant, which means I don't have any backups, I don't have any spares. Let's look at what this means to us as far as performance. I have enough capacity to meet the needs. So if I need 100 kilowatts of power, I have 100 kilowatts of power. What I don't have is a spare UPS to provide power if my first UPS were to go down, or if I were doing maintenance on that. So any planned work that we're going to do, let's say we're going to do our preventive maintenance on my UPS. When I do that, I take my UPS offline. That means I don't have a UPS ready for my equipment. If, while I'm doing my maintenance, I get a power outage, all of my servers are going to go down. Right? So that can affect my computer systems, my end users, my applications, and so on. The operational impact on me is I get interruptions from both planned and unplanned events. So doing a planned event like maintenance is going to impact me. An unplanned event like a power outage also impacts me. And any of these unplanned outages are going to impact my computer equipment. The infrastructure must be completely shut down at some points to perform my preventive maintenance. So it's important that we know that. Let's look at Tier 2. Now, Tier 2, we're going to add a redundancy component. I'm going to add redundant capacity components. So if I have a computer room air conditioner to provide my cooling, I have a spare that will take care of that in case one of my cooling units were to go down. So I've added redundancy in my components, but I still have a single distribution path. I've only got one electrical path for my equipment. What's that mean to me? I can remove my redundant components on a planned basis without having to have my computer room equipment shut down. So I can take one of my computer room air conditioners, my CRAC units, I can do maintenance on that without having to worry about not having enough cooling. Okay? My distribution path, on the other hand, my electrical path, would require a computer shutdown. The operational impact on me, I'm still susceptible to interruption from both planned and unplanned events. And any unplanned outage may impact my computer equipment, may give me some downtime. Okay? Let's move to Tier 3. Now we're going to add in a key component. We're going to add in multiple independent distribution paths. So we're going to have more than one way for the electricity to get to my server. Very, very important, because what this allows us to do is to do maintenance. My IT equipment now is going to be dual powered, so I'm going to have multiple ways to power my electrical equipment. Now, every component can be removed from service on a planned basis without impacting any of my computer equipment, right? So you can see how this is going to impact my availability, right? It's going to really help me to be more available because I can now start doing maintenance. I have enough capacity to meet the needs even when I take some of the equipment offline. Operational impact, I'm still susceptible to interruption from unplanned events, but I'm taking control of my planned events. So I can do this planned maintenance. Let's move to Tier 4. Tier 4 now, I have multiple independent, physically isolated systems. So what does that mean? I've got enough capacity to take any piece of equipment out, and I've got multiple distribution paths, meaning that no matter what I do, basically, my IT equipment is going to stay up. I have continuous cooling to allow me to stay cool even when I take systems down. As a result of that, a single failure should not impact my computer equipment. Right? Every component can be removed on a planned basis without impacting anything. So what I've done is that this is as available as I can get, right, when I move to Tier 4. Let's just look at what this is going to do altogether. When I get to my tier requirements summary, right, here are my different tiers that I have, Tier 1 through Tier 4. And then down the side, I see how my different, the different areas of availability. So when I look at active capacity components, at Tier 1, I have N. N means I have enough. I have what I need. Tier 2, I have N plus 1, which means I have as much as I need, plus I have some redundancy, right? I have the ability to take something offline. And then Tier 3 and Tier 4, I continue to have that N plus 1. Distribution paths. On Tier 1 and Tier 2, I only have one. Tier 3, I introduced this second distribution path. And what's important about that is if I look down to the next line, concurrently maintainable. Notice it's no and no for Tier 1 and 2, but it's yes for Tier 3. It's because I've introduced this extra distribution path. I'm now fault tolerant when I get to Tier 4. I've compartmentalized, which means everything kind of stands on its own when I get to Tier 4. Continuous cooling, I introduced that in Tier 4 as well. Class A cooling just means that the cooling's going to be on regardless of what my power situation is. And most importantly, when we get to tiering, let's look at availability and downtime. So what's important about all this tiering is availability. Tiering is all about availability and how much downtime we have per year. So if you look at this final component here, this downtime per year, in a Tier 1 you see 28.8 hours of downtime. That doesn't mean you'll always have exactly 28.8 hours. You may have a whole year where you have no downtime. But on average, you're going to have, close to 30 hours of downtime per year due to planned and unplanned events. At Tier 2, that goes down to 22 hours. At Tier 3, you see the big jump. We go from 22 hours average down to 1.6 hours. That's because of this alternate distribution paths and this concurrent maintainability. So it's very important when we look at data centers to look at availability. That's one of the key components. We'll talk more about the kind of an overview of data center in the next module. But some of the key things we talked about here was this tiering, this availability, some of the cost factors for building a data center, right? So all very, very important that we look at this when we get to the design of a data center. We look at all of these things up front really at the design level. If you have any questions on anything that I've covered in this module, you can use the question comment box that's provided, and that will send an email directly to me, and I can answer any questions you have on anything we covered in this module. Thank you very much for joining us. I hope this was important information for you, and we'll continue on with the next module.